today, basically what we are going to look at, what is data modeling? Data modeling is creating relationships of all the data you're working with. Mostly we have a lot of data that we pull in to work with, but it's not related. What I can say, it is not the same data, but at some point you need one source of truth. That you have data from operations, you have data from HR, you have data from finance, you have data from the third party vendors, suppliers, and all that. You need to bring it all together, because when you start doing analysis, there are some things that you'll not work with when they are still broken. You just have to have everything into one space, and you need to have all the data sets related to each other. And that's what we are going to look at. How do you monitor the relationship? How do you create the relationship? How do you maintain the relationship such that it can never break as you build the other front end of the visuals or the report itself? So this also is part of the foundation before even you start thinking about how do I build my dashboard, or how does my dashboard look like. It is the first thing that you first focus on. First of all, you ask yourself, all the data sets I've pulled in, uh, are they related? And if they are not related, what should I do? So, and this is the session today. So today we are going to look at, to focus on that. As always, we are going to start with the terminologies we use. Then after then, we shall automatically kick off with some practicability of it to make sure that you get where we use them. So this is, we call data modeling. This name of late, it has changed. They call it schematic models. Schematic, we are going to look at that, like how you see this word schema. So schematic models or schema design. So it still relates to the same. Now, what we want, or before we leave the milestone for this call, you need to understand what's the difference between a fact table and a dimension table, because these are the two types of tables we deal with. Then what is a star schema design? How do we create table relationship in the model view? What is cardinality and how do we deal with it? How do we differentiate the different types of cardinality? This is cardinality. It is where you hear one to many, many to one, something like that. That's what we are going to look at. Then how do we build a calendar table? And we may touch it today, but most of the part here, it will be done in DAX. When we start DAX, that will be next week. Then we are going to look at the naming convention and the best practices, how we are supposed to do the namings. Then obviously, at some point, we shall look at how do we use the AI models to support you to create or advise you on relationships. So obviously, we shall do something like a practical part of it. We bring data together, then we see how we can create models. Then after then, which means when you're done with all this quiz should be active for you to take. Okay, as always, we'll use still Notebook LM. I don't know how you find Notebook LM in other ways of work, how you're dealing with it, but it's something that you shouldn't drop a ball on. So we'll open one of the data set I was dealing with. Obviously, this was picking from YouTube, but still it's okay. So let's look at, first of all, the terminologies. used here. What are the major terminologies we use, the concepts? So when we come to Power BI, or even data analysis, there is what we go for first, defining the types of tables. What is a fact table and what is a dimension table? There are many definitions you can get outside there. But for today, we are going to go through just the major differences that defines either of the two. So, first of all, a fact table, I will want to first run through them, then you can understand, then we drop back to this. A fact table is a table that receives data on a daily basis or that receives updates on a regular basis. That if you have a table in your dataset that stores sales, revenues, costs, expenses, those tables are called fact tables because at any time we are receiving new updates of dataset. Those are the fact tables. Now there are these tables that you have in your business, you have in your dataset, but they can even spend 5 years without receiving an update. An example, if you have a company and you have 3 branches and you have a table in your database that shows branches, branch A with all its details, this branch A is in Wakiso, this village, this branch B is in Kasese, this branch C is in Mbarara. You can even spend 5 years without scaling up for another branch. So it means that you're going to spend 5 years without updating that table with a new transaction. That is a new branch. So we call that a dimension table. It gives you the dimensions to whatever data you're running. It just explains. It is qualitative. You don't have data that you're going to sum up or to aggregate in dimension tables. All what I'm talking about there are the differences between fact tables and dimension tables. Then also the other thing is these are the tables that carry definitions of different parameters in your dataset. Let's say you have a customer table. It has all the details about the customer. They define what a customer is. So that becomes a dimension table. Because you may even spend a week without receiving a new customer. Even though you receive customers on a daily, in that table you're not going to have aggregatable data. Even if you have numbers like age, you're not going to add the age of all your customers and you say, I have customers who sum up to 1,000 years. So what? Because that number doesn't give sense. So those are the few differences I can give, but there are very many differences out there that you can have differences between fact tables and dimension tables. Now, when you look at this picture, the picture here sharing on screen, hope my screen is visible, guys. Just checking on my end.
Yes, it is visible.
Okay. So looking at what we have in dimension tables, you see there is location, there is customer, there is product, there can be prices, location. So you find that all that such data sets, they define, if you have a product, let's say I'm going to use an example of cement, you have a product multi-purpose. In the table you have in your database that defines products, you'll find the name is multi-purpose, you have a material code, you have the lab details like the levels, how it is measured in the lab. You have all the details that are in regard that particular cement. The same another product. So there is nowhere you're going to find that there is a value that comes in on a daily you're supposed to sum. No. So that we define that to be a dimension table. So here you say that another name you can call them, it is a business entity. Like customer table, it is a business entity because it holds all the customer database. It defines who a customer is. Who has joined, Liz? Okay, Liz, you can mute. Then we have. You have a question? Liz, you have a question?
No, my apologies. No, I don't have a
Fine.
question.
Then for the fact tables, these ones we call them events, or you can call them transactions. These are the tables where they are updated nearly every second. Sales transactions, you see website visits, and name them revenues, costs, and all those tables I'm talking about, they have aggregatable data that we can aggregate that data and get the sum, the average, as name them. So that is the way how you can define the two tables. And when we come to data modeling, you must have to first define the tables you're running with. The moment you're done defining them, then you can know which one falls where. But before you do that, it's going to be a challenge for you to create relationships of what you don't know, how to categorize it when you start doing your visual and reports. Now, dimension tables, it's context. Fact tables, it's measurement. Now I think it makes sense that here we deal with qualitative and descriptive data sets. Usually it contains text-based information and they are used for just filtering, slicing, dicing reports, that is separating reports here and there. Then when we come this side of the fact table, that's where we find the quantitative events. It represents the distinct business events such as sales, inventory, capturing all the other costs and expenses and name them. The how much, how many, and here we have the why, the what, and the who, and the where, and the why. So who is the customer? What is the price of the product? Where does the customer live? You get that is dimension. But when we have something that it is quantitative, we are supposed to look at how much, how many, then it becomes a fact table. Then when we look at the other difference is the examples here, most of the cases we call these ones master data tables. Like you'll have someone on your team who will always tell you that let me update that in the master data set or in the master table. Like those people who do pricing like in ERP and all that. You'll find that those master data tables, they are dimension tables. But the transactional data tables, always, sometimes businesses have internal developed customized systems that handle these. That an ERP will not handle this, but you'll have a system maybe at the web reach that is handling these data tables that are transactional. And here, that's where you find sales, orders, inventory, name them. So that is, if I can give the difference in a gross of it, this is the content that is there, descriptive or qualitative, this is quantitative. Then this grows slowly. I've told you that you can update 2 customers in a month. But here, every second that you blink, the business is selling, the business is costing, the business is expensing. Then here the role for this is always to make filters, slicers of data. And we realize it even in our data sets that we are going to have those tables, but the only thing we shall be using those tables is to create filters. That if my customers or if the people who are going to view my report, they want to filter by company or by branch, then I will put a filter for branch. Then here, obviously, I have talked about this several times. It gets aggregated sum, average, count, name them. I think this one gives a holistic understanding of what a fact table is and what a dimension table is. The moment you understand that, then we are going to roll into now what do we denote to be a primary key and sorry, this should have logged out already. What is a primary key and what is a foreign key? I think this one we are going to open Power BI. We first load our data, then we can go through that one by one. So now that's where we are going to look at how a star schema looks like. I don't want to define it maybe before we go through it. Then we are going to create relationships and the table relationships in the model view, and we are going to look at cardinality. So cardinality is where we find one to many, many to many, one to one, and we want to know the meaning. What is one? What is many? Now in dimension tables, you'll always find that every material appears there once. Its code appears once because it is a dimension that if you have a customer, if you have an employee in HR, that employee appears once. There is no employee who appears in HR data twice. No, that employee is not there. So that is dimension table now. But when we go to the operational data, this employee is going to maybe have targets every month. You'll find in that table of targets is appearing like 3 times. Or this is an employee, every order that comes through, it comes tagged, attached to them because they manage that region. That means that employee is going to appear on every order, appear there many times. And that's what you hear, one to many. That when we combine these two tables, the dimension table is having one, and the other table we are combining it or relating it with is having many transactions of that identity. So that's what we call one to many, and it is the common cardinality we use. Then where you find it is one to one, it's where it is a match. You're having two different tables, but in every table that identity appears there once. Then many to many is now if you're comparing, which you should never try to use. You can use it on a few scenarios, or even less, or even no. Many to many. That is like you're comparing, let's say, a table that is coming from finance that they have been using to give advance to employees. You're comparing it with the operational data set, where that employee is appearing many times in the data set for operations and also is appearing many times in finance table because he has been given advance nearly every day. So that is many to many. Now, when we come to data analysis, that relationship can never give you mileage, can never support you in anything. It will just create problems for you. So what we do there, we always have to create a medium table, which we call a dimension, that connects these two tables, of which a dimension table will have only one employee, then that table connects to the operation and it connects to the finance. So what am I talking about if I try to annotate here? That you're having a table, or let me first hide that stuff behind. Okay, let me use a yellow one. So here you're trying, you have a table. You have a table from finance, you have a table from operations. So this is finance and this is operations. And here we find that we have employee data set, that this employee, they have been giving him, let's say employee A. He has been given this employee A, He has been given advances near every day. Then also when you that is operation. He has been having sell orders that come through that their names are attached. Then even in finance, the same employee is being given advance nearly every day. So you'll find here employee A, they gave him advance. Employee A, they gave him advance on a certain day or even in the afternoon. So you making a relationship between this field and this field, it is you're throwing yourself in fire. That you're going to have issues when you're analyzing these two tables. What do we do? Even though these tables may have different columns that have a lot of aggregation data you're going to use, what you have to do is you have to make a table in the middle here. You have to create a table in the middle here that we are going to call employee table, right? That we are going to call employee table. That this employee table is going to have only unique IDs for that employee. Let's say you have A, you have B, you have C, such that you connect this to this, then you connect this to this. That's how we do it. And when we come to data analysis, we call this normalization. Splitting two tables that we're having many to many, and you create an intermediary that can connect them. Such that when you're creating your slicers, you create slicers by picking this column onto the filters. Such that when you select here Kenneth, it will filter data this side and this side at once. But if you used these two tables separate and you picked this and put it as a filter, when you filter Kenneth, this data will filter in your report from finance, but data from operations will not filter. That is the problems you're going to face when you do that. So I think this one I explain it better on the reason why we don't do many to many. Obviously, we are going to reach that and you're going to look at the many to many I'm talking about. Okay, let's drop to Power BI. We are going to open one of our data sets. I think we shall use this. So I will not go back into extracting data from wherever it was. We did that before. That is getting data. Then after getting data, we did all the transformation. And now we are just going to focus on data modeling. So we said last time that we had number one, which was the report view. We had number two, which was the data view. We had number three, which was the data model view. So this is where now we are going to focus on today. How do we create models? So you'll understand that now we have gone through one, we have gone through two, we see now our data is loaded in number two, now number three. How do we create relationships for this data? So that is exactly what we are going on. And here we are. Now already this data set is being loaded, was loaded, and we already have relationships created. I'm going to delete all these. So I'll select all of them and delete. Here, go ahead and delete. Okay. So, Andrew, you're back. I know network has been challenging you, but the good thing is the call is...
Seriously?
The good thing is the call is recorded. Maybe you'll review through the recording. Okay, it's good you're back. Let's hope that you don't go back. Okay, I have deleted.
Now I've settled.
I've deleted all the relationships that are there. Let's look at what we are dealing with. So here we are dealing with all these data sets that we collected last time. We moved a dimension city. So if I click on this, now when you look at this data set, now you can easily now tell what I've just explained, what is a dimension table. You see that this data set has a city ID, city, it is defining the city throughout. And it is defining the city, the state it is in, the country, the sales territory, blah, blah, blah. So there is nothing here we can aggregate. Automatically, this is a dimension table. Let's come to the customer table. So when you look at the customer table, the same thing. We have the keys here. We have the customer name, the bill to customer, that is maybe the business name or the account name registered, the category, the buying group, primary contact, the credit limit. You can't add these credit limits. Every customer has their own credit limit. It is just a parameter we compare when we are giving them credit. So still this one is a dimension. Now there is the date. This date, if we are running data for 2016, then it is 2016. It runs from January 1st to January 31st December. If you are running with 2 years, well and good, still it is that. I think this one is running more than that. So it means that if I can try to select here, yeah, we have 4 years actually, 13 to 2016. So it means that we can't add anything else, like we can't add the year for 2026, yet our data is not in 2026. So it is also dimensional. Then dimension table. Then the employee data set. So when you look at this data set, it is just having all descriptive parameters. Nothing that is aggregatable, nothing that is an event. Then when you look at the dim stock item, when you look at all this, quantity per outer, there is tax rate, there is unit price, there is a recommended retail price, there is a typical weight per unit. All this is descriptive. Nothing is aggregated data. So that now gives you a definition of what is a dimension table. Now, when we come to the fact table, which we had fact cells, I think this fact final was not meant to be hide from the report view. We don't need to look at it here. And even I think this was also working with one of the class. Let's hide it. You can always delete even from the model such that it goes for good. So now, when we look at the fact cell, here we go. It's loading. Here we go. Now, when you look at the fact cell, now what you realize first of all, you'll see that it harbors all the keys from all the other dimension tables. You have a key from the sales table, which is this, which means in its own table, this one we call it primary key. Then all these keys, this is a key from the city, dim city. This is a key from dim customer. This is a key also from dim customer. This is a key from dim stock item. These are keys from dates because these are dates, invoice date and delivery date. This is a key, a sales key, which is from employee. You get, now it is here where you get the invoice ID, which still is not aggregatable. Then now we have aggregation here. You can aggregate quantity to know how many quantities were sold in a day. Obviously, price is just a parameter or an identity to be used for getting amount. Just quantity times unit price, then you get the amount, maybe minus taxes if it is tax inclusive and all that. Then these are profits, these are total dry items, total chill items, lineage key. This is descriptive, but at least we have a column, at least one column that is aggregatable. It stands to be a fact table. Now, something I didn't talk about was the naming conversion. So the naming convention we use is always to make sure that we define our tables. You always use the word fact as a prefix in front of the table. You can say fact revenue, fact sales, fact expenses, such that when you're doing your model, you easily identify which one is a fact table, which one is a dimension table. And that's why you see here they have used DIM. That is the discipline you'll always use, such that you don't confuse yourself. And you don't keep cramming them like this is dimension, this is this. Give them the naming in the naming convention as you're planning how you're going to name them. You can include an underscore, but I always tell people if you don't need the underscores, then always join the names. But every word in the name starts with a capital letter, such that you can easily tell that these are two words, DIM and customer, DIM and date. So that's how we run with the naming convention, which we have already talked about. Now, when you have loaded everything here, now we have seen the visibility in the data view, everything is fine. We always now drop now to data modeling. And these are the tables, the way how I think I will need to expand. Sorry, trying to expand here. There we go. So this had already deleted it actually. I can right click on it and delete it from the model. Guys, anything you never need in your analysis, put it aside. Otherwise, you're going to have a lot of clusters here, and most of them, you're not using them, it is just confusion. Now, here when you count very well, we only have one fact cell and we have 5 dimensions. But it will not always be like this. At some cases, you'll have more than one fact cell and you'll be having more than, the dimensions are always more than one, most of the cases. So, how do we create our dimension to arrange it in the right way? Most of the cases, you can arrange it, put them in rows. Either you put the dimension tables at the top and you put the fact tables at the bottom. If there are more than one, still you put all of them. Just wait a minute. So this is what I'm talking about. That if you have dimension tables, you can always have them in that row. Then you have your fact cells in another row like this. Just to make sure that you don't have a lot of confusion here of relationships, because everything here is going to get a relationship with the fact table. So you'll find that the relationship will be coming like this, like this, like this, like this, then like that, and it remains neat. Even if you're having a fact table more than one, let's say you have that, then let's say you have even this. Still, when you're having the relationships being done, it's going to be easy that this will have a relationship with this, maybe with this. This will have a relationship with this, like this, maybe with this. This will have maybe a relationship with this, or even with this, right? Then also you'll find this one is having a relationship maybe here and maybe a relationship with another table this side, like this. Till at the end of the day, you're going to find that your model is neat. Someone can reach in your model, can look at your model, and they understand in less than a minute what you're doing, which tables are in your model. But the moment you start getting confused, or you even the owner, you reach your model and you first go and get water from the dispenser to come and read again, then know that there are some things you skipped that you need to refine again. So that is something you should always take. That's why we spend most of the time doing transformations, doing modeling, doing extracting data from wherever source it is, such that when you have refined these three, when you start creating DAX, the analytics expressions, it is easy because everything is named right, everything is cleaned up. When you start creating visuals, you don't start assuming which goes where. What does the business want to look at? You have already done that planning. Because if you have done a project, developing a dashboard is a project. And you can't start any project without planning. So you always have to first plan. You have to talk to the stakeholders to understand the concept of each and every field, column, row that you have in the datasets. So when all this is done, now we are going to see how we create relationships. Here we go. I hope this is enlarged enough. You can read this. Now there is another scenario where we always say, okay, if it is one fact table, why does it have to be alone down? Then, and I stretch the dimension tables, which are many, and I feel that I will want more space on the right or on the left. Then that's where we come in and say, okay, if it is that, you can always bring these tables around like this. Then you bring this here, then you bring this at the bottom, maybe there. So if I zoom out this again, like this. Why are we doing this? To make sure that we don't clutter whatever we are working on. And the moment you're done, always making relationships, you can collapse these. You see, when you collapse them, you don't look at the columns, but the relationships will always be there. So why we collapse them is to make sure that you can easily read the table names and know which table is matching with which one. So we can again expand this. We'll say expand all here. It expands all. If you right click on one and you say collapse all, it will collapse all. So even after we have done relationships, this is something easy you can read. And you know that I have this table, I have this, 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 in just less than a minute. So let's expand all, then we look at how are they related. So we have already seen that in the employee table, there is an employee key. And in the fact table, there is a sales person key. So it is upon you, if you wanted to change this to employee key, then you can change it from transformation. But we may not need to change it because maybe a salesperson, some are contractors, some are maybe staff that we appraise them on performance. Maybe the contractors you don't have them, something like that. So you can leave it the header like that as how it is. So when we denote that we need this and this, which means we have to bring them together. Let me first annotate again. So which table here do we need? We say we need this column. No, not yellow. We need this column and this column. They are going to be matched together. Then obviously here we are going to look at others that are that side. So what we are going to do is dragging this and dropping it on top of that. It will automatically create a relationship. Now what I talked about last time, that here every employee is appearing once. Here every employee is appearing once. And here every employee is going to appear many times because there are many orders that are attached to them. So we shall find here it is called now many. So this is always put in a star form. So we call this cardinality one to many, or you can call it many to one. That is the reason why we have that cardinality. So I will escape this. Then we have our business go on. So here you'll drag the sales key and drop it on top of the employee key. Even if you don't drop it perfectly on the employee column, don't mind. I'm going to make it intendingly that I will not perfectly drop it on the employee column. So when you don't drop it there, it will always open this box. And this dialog is going to show you that the tables that are, the columns that are selected, that they are the ones you're connecting. Then you can verify or double check that this is the employee key. This is the employee, the salesperson key. Then here I look for the employee key. Now you see, because it is already wrong, it is giving me an error here that it is many to many. And it is giving you a hint that, by the way, you want to connect many to many. I don't know whether what you're doing is right. So when I select this, it automatically refreshes to a cardinality of many to one. It means that this fact table, there are very many, and this employee table, it is one. That's why it is one to many. So when you look here, we have many to one, we have one to one, we have one to many, and we have many to many. Now, what you should always focus on, and what will always be the right channel you're taking, they are these. It's many to one and one to many. This difference comes because of the way how the tables are set. The moment you put this at the top, this one at the bottom, it becomes one to many. It no longer becomes many to one. So I hope that explains it. So if I said, let me put the dim employee up, I will come here and change dim employee. Obviously, I can't change to it because it is already down. So if I change something here, I can change to something else, then I will find it here. Then I come and put dim fact at the bottom. Now here I can say, I'm looking for salesperson with employee key, then you come and look for salesperson key here. This is it. Now you see this time it is one to many. It is no longer many to one. It is because of the order of what you have here. But at the moment, the order doesn't matter. But the order will matter when we reach in an advanced level, where we start looking at the cross filter direction. So for now, give it a deaf ear. We shall look at it, or you'll read about it when you're doing your research on advanced levels. So here I will go ahead and save. The moment I save, it's going to create a relationship. And you see it is creating a relationship like this, many to one, like that. The moment I double click on this, I will open again and it will show me all the details. And mark this, that this is made, it is made active. The moment I uncheck this and do OK, it will be in a dotted line. But that doesn't mean that you can't use it for relationships. So we are going to find that scenario when you're making a relationship for two columns in one table on two maybe different dimensions or the same dimensions. So I'll double click on this and make it active again. So by default, it is always active. Okay, now let's create other relationships if there is no question. Now, the other relationship on customer, we have a customer key, then here we have a customer key. You already know this offhand because you have done enough exploration in transforming this data. So I will just drag this, drop it on top of that. It will open the box, obviously, because I was perfectly matching. It is already that. I'll go ahead and save. Then we do another one. Wait a minute. I want to check whether we're still recording. Okay. So I will do another one. Now for stock item, we have stock item key, and here in fact sale it was called stock item key. So I'll drag this and drop it here. Then go ahead and do OK. I'm not even putting our second verification I because I did the perfect thing. So you see that one is still one to many and the direction is downwards. So here is dim date. Now let me start with city. Here we have, let's look for, well, city key is here, then the city key is here. The moment I drag this and go ahead, boom, it creates that. Now, what is pending is the dim date. Now you'll understand here that we have two dates. the delivery date and the invoice date. And we also need to relate all of them with the date, because at some point you'll create a report where you're referring an invoice date, or you'll create a report where you're referring a delivery date. But obviously for this purpose, the delivery date is our base. So, which means I will start with it since it is our base. So I will drag it and put it on the calendar or on the date column. You will always have a date column on your calendar table. So that is it. Go ahead and do that. So you have seen that is active. Then I will drag this again and also drop it still on the same date. Now this automatically becomes inactive. They uncheck it automatically. Even if I force to check it, it is going to validate and it will tell me there is an ambiguous path between the fact cell and the dim date because there is already a relationship. Take an example that you're married in church. That is now the first active relationship. And you go back to church to marry again. They will tell you, no, we are not accepting that. First, go and make a divorce. That means that you're going to paint the other relationship as an inactive one, like as a curtain, a dummy one, like it is in the background. You'll have your partner, but not recognized in church. So that is the same thing you can take. We always leave it inactive, but you can have kids and all that. So that's what it means. You can have two relationships coming from the same table to another table, which is still the same, but they can never all be active. So when I'm done, this is exactly how smart your data model should be. Now, this is where we derive the name called Star Schema. Star Schema because it is in a star model. So when you look at this, you let me make some drawings here. So when you look at this, you see that this one is matching there, this one is matching there, like this. This matches with that. Again, this matches with that, and this matches with that. What have we drawn? That's a star. So that's why we call it a star schema. So we have snowflakes. Snowflakes, that's where you'll have many fact cells, many fact tables, many dimension tables, and even the dimension tables themselves have other sub-dimension tables. Like you have a table of category, and there is another table attached to it of subcategory. So, and it is not common, but still, even what I've talked about, it can always be put in a way of a star schema. Star schema is a common one because it helps us to easily identify our models or relationships. So I think drawing the star doesn't require me to go back and explain or define what is a star schema. But all in all, let's come back to, no, not this, here, defining a star schema. Star schema life cycle. Let's look at it. Now the star schema life cycle, here it is. You have a lot of data in a chaos. You first investigate and put aside these are dimensions, these are facts. Then you make an iterative building when you're putting together the fact cells. Like I said, you can bring some columns together to make a table, or you merge. We did merging. You merge like two tables to make one table, which is, let's say, a fact cell. Then after you have done that, phase 3, you do the final polish, where you put the standardization like dates, formulas and all that. But let's come to this, the golden rules of modeling. 1, star schema priority. Fact tables must sit in the middle surrounded by dimensions, never connect facts directly to facts. Even if we have I think I explained that at the start. You have data from operations, data from finance, they are fact tables. Never connect them directly. Create an intermediate dimension and connect them together. Then there is another rule. Every column must earn its place. Make sure that you don't have columns you're not going to use in your analysis. Remove them. Removing those columns doesn't mean that you're deleting them from the source. But what does it mean? You are getting them off your radar of analysis. When you check our data set here, you'll see that we remain with few columns. Let's say when you come to dim customer, how many columns are these? They are not even more than 8. So when you go to CT, there are few columns. But even these should have been gone because we never needed this, the location, the last recorded position. Just you needed to remain with only the columns you're going to need. Maybe you're making filters, maybe you're running a comparison bar graph for the countries or for the sales territories, something like that. Then what else were we talking about? Another golden rule, validated totals. So make sure you do the merging, make the validations. What do they mean here by validations? If you know that your data or your dimension data that has 40 customers, and after you have done transformation, this data has increased from 40 to 80, there is a problem. It means there is a transformation stage you did and it multiplied the number of customers. Either every customer was split, maybe you did an pivoting and every customer was created twice, or maybe twice because they are having different locations where the residence and where they were born, something like that. It creates maybe 2 rows for every customer, which is not good. So you must always know the numbers you're running with. So the naming convention, we have already talked about this. So the naming convention, I want to enlarge here, such that it is visible for all of us. Now the naming convention we have, if you are naming like fact tables, first of all, you have to use them as a prefix. You can use it as a fact, then you add the name of the table. You can put an underscore or you can leave it. I said when you leave out an underscore, make sure that every word starts with a capital letter, like how our data set is. For dimensions, still the same thing. Start with dim, then add the name of the table. Then there is the surrogative key. Maybe that is when you're adding something at the end, or the keys that the foreign and the primary. You can always also rename them. Like you have seen, our data set here has the word key at the end. You see, we easily tell that this is a key. But you can imagine if these namings of these column headers, we are not having that key. We wouldn't tell that this customer key is the key we need to connect this and the customer table. Because when you click here, you see it is the key that we used. So it is always good when you are doing your transformation, identify the keys. That this is a primary key in this table. The customer key is a primary key in the customer table. But when we go to the fact cell, the customer key is called a foreign key because it comes from a foreign table. But it is here in the fact cell to define the transaction for that customer. So it becomes a foreign key. So every table will always have a key. And if it doesn't have a key, try to create one. Try to see whether you combine 2 columns to create a unique identifier. That is also a scenario where you find data doesn't have a primary key. If it has a primary key, know that a primary key is always a unique identifier. What does unique mean? Unique means that it can't repeat itself in that table. So I remember we talked about that. Let me go to transform, then I just pass a glimpse on that. But meanwhile, if you have any questions, please feel free to unmute. I see one in the chat. No, it's not a question. Okay. So here what we are talking about is this. So when we come to this dimension table, let's click on one. It was still refreshing. That's why when I click on another table, when it was still refreshing, it shows a question mark. So you can always go back, you leave it to refresh, or you force it to refresh a preview. And you get rid of always doing a refresh all, not until you have time. If you are doing things in a rush, don't refresh all. Refreshing data here to look at it is not mandatory. That data has already refreshed to your visuals. This is just a preview of what you're looking at. So if you are not if you are on a hurry, don't refresh all because it will take time to refresh everything. So that is a disclaimer you need to take. So if you say here refresh all, it refreshes all of them, but minor few it may take short time, but don't do that when you're dealing with data and your boss is just standing beside you. You're showing him what you did and it can't refresh. You spend 2 minutes, you're standing there and you tell him, I know it will refresh. And that's how we lose trust. So some of the things you don't do them when you don't have the time. So what I was talking about is when we go to view and we activate the column distribution here, you'll find that this table, this column here, the sales key, it has 1000 distinct and 1000 unique. What does it mean? That 1000 values are all unique, they are not repeating themselves. But, and for this one, what does it mean? That 72 values were found having more than one value, but when they count a distinct, like 10 Kenneths, I just take one Kenneth. 3 Andrews, I just take one Andrew. Then I count, I have 3. Elise, one, maybe 20, I just take one. Then I say I have 3 people who are distinct on the call. But when you look at the data, it is over 40 transactions. That's what it means. Now, when you look at 72 distinct and 1 unique, it means here, like, one value was not repeating itself out of the 72. It means the 71 were repeating themselves. The same thing here. Now, when you look at 3 distinct, 0 unique, it means that all of them were repeating themselves and we only got 3 distinct. That's what it means. Hope I've explained it. Someone was telling me that it is all the same, that is just English, distinct and unique. But my friend, when we come to data analysis, you need to get them different. Because even when you go to Excel, there is a formula that starts with equals distinct, and there is also a formula that starts with equals unique. You can barely get different answers, and the answers, they are here. If you get equals unique, you'll get 17. Equals distinct, you'll get 209. Yep. So we load and close this. Now let me get questions, but otherwise, what we have done right now, I can say we now have data modeling. The only thing is now to try and make sure that we do all the practice we can. You're going to find other documents or data sets where you only have one file. And you ask yourself, how am I going to deal with that one file in the model? My friend, you are supposed to normalize that file. What is normalization? Normalization means that get different dimension tables from that file. Then you get dimensions. Then you unclutter that file not to have many columns because you want it to remain one. So we shall find those such data sets, and the process is called normalization. in data analysis. It is called normalization. So when you see anything where they're asking normalization, it means that there was one data set which had like 50 columns, but those 50 columns were broken into, they put the customer data separate, they put the product data separate, they put the city and all that separate, and we call that normalization. Then after that, you have put them separate, load them, and you get something like this. Then you do the relationship. It means that the 50 columns you had here, and you have remained with 15. It has uncluttered a lot of repetitions you had because these tables were merged here. You get, the moment you merge these tables here and you bring them into this, if you had 1,000 rows here, they are going to triple or even quadruple to like around 4,000, because every data set here, it will come and make a new line and repeat the transactions that are here. I don't know whether that rings a bell, but that's it. That's normalization. Any question? Do we have any question? Or we can go back to our notes and review what we have done and what we haven't done. Okay. Here, but let me confirm that you're there. You know, it is an evening where you may be tired and you have already slept off. Okay.
Yeah, Chris.
Okay, fine. Now, when we look at the outline here, we have defined and differentiated fact and dimension. We have defined what a star schema is. We have created table relationships in the data view. We have done that. So I have explained cardinality. We have built, we have not built the calendar table, and I can't build it right now because it will need DAX. I don't want you guys to imprison me. Starting DAX right now, it is going to be a mistreatment I will have created. But we shall talk about that when we are dealing with DAX the other side. Then model naming convention, I've talked about this and the best practices. Then the AI assisted. Now the AI assisted, this is the AI assisted. Let me show you. If you fail to get the data model, always you can go and ask. If you fail to get relationships, you can always export your data into, or you can export the structure itself. So let's do it together. Here, I'm going to delete all these relationships. And if you don't want to delete all of them, this is where you go. You go to manage relationships, and here they are. I'll check here and say delete all. And obviously they will always first ask you, are you sure? Because the moment you delete relationship and you already have a dashboard that is glittering the other side, everything is gone. At that point, whoever is looking at that dashboard is going to start looking at errors. So you have always to be sure. So I will delete this since I'm sure I have nothing attached to this. So boom, that's gone. Then, okay. Now, I'll make sure that all my tables are expanded, right? And it is always good. That's the purpose why we do transformation, to make sure that you remain with the only columns you're using. So I will expand this. I'll expand my fact table here to make sure that all the columns are visible. Will they ever be visible? Or I put this aside. So I will put this here. Then I have this because I want to expand everything that is oh, sorry. there. So wherever we have a scroll, so with date, even if I don't expand, the date is already visible. So here, that's. Now, I'm going to take a screenshot of this copy. Then I'm going to look out for my friend ChatGTP, which we all have. Then there is one of the students I had one day asked me that, you know what? I feel like ChatGTP is like cheating. In this era we are, ChatGTP is a tool of work. There is no way how you're going to do or run a report for a week when a report can be run in 4 hours. There is no justification you're going to give. The same way I answered that person is, in primary school, we used to have multiplication tables behind the book. And every time you're in math, you feel like your book should not be covered, because if the mathematics book is covered, you're gone. Because you'll have to keep removing that cover to check on the multiplication table. I don't know whether that is the experience for all of us, but that's the experience I went through. Then when we reached secondary level, the multiplication tables lost meaning and we had to have calculators. Senior 1, Senior 3, you have this Casio calculator, which is not having scientific functions. I reached Senior 6 because I was doing sciences. I was meant to have a scientific calculator. That was mandatory. So that means that every environment has it has a working tool. So when you took a calculator in primary, it was cheating. That's the same thing. If you use ChatGTP in 2000, that was cheating even at the place of work. But right now, it is a tool. So never fear to open it and use it. But remember, data governance, you don't have to use it for the company data when the company has not authorized. How does the company authorize? If they have given you access to Copilot, it means they have authorized you to use Copilot. But still, you don't share sensitive data with the chatbots. Right now, they are still loose that you share passwords and someone can search for your password on the internet because you have already put it there. So hope that I've explained it well. And by the way, we have a free webinar that is going to be at the end of the month. You will not need to miss that. It's going to be building dashboards using AI, entirely AI, without Power BI, without Excel, without anything, but building a dashboard with just AI. So we have pasted our structure of the data set here of our model. I have not given data to AI, but I'm going to ask it with the structure of the models shared, please advise the relationships I should create, or create a PNG with all the relationship, marking out the keys and the columns that are related to each other. So what I've said, I'm going to speak it such that we can look at that typing. So you are a data analyst. The shared screenshot is a data model or schema for a data set I'm running with, doing analysis. I want you to advise the relationships to all the tables given in the screenshot, or even create a PNG that maps out all the relationships, marking the columns that map to each table. So what I was using is called Whisper Flow. Whisper Flow allows you to dictate and the text writes. You get. So I would have taken 3 minutes to type all this and even thinking, is it the right spelling? But Whisper Flow even does the punctuation for you. It is different from this even ChatGPT has this. You can dictate, then it transcribes, but you reduce on the typing when you have these tools. So I'm going to run this because I've told it exactly what to do. Now, those who have taught AI, but I think on this call, none of you. We have a model the way how we prompt. First of all, you give AI, you give it a role, then you give it a context, then you give it an output. If you have any constraint, what it shouldn't do, you tell it, don't do this, don't do this. I want you to draft for me an email. Make sure that it is humanizable. Don't use M dashes. Don't use perfect words in English. Make it plain, something like that. So you give it constraints. So that is the flow how we prompt with AI. You give it a role, you give it a context, you can even give it a detailed on what to do, you can even give it a sample, then you tell it how to output. So for me, I've told it to map out for me the relationships and output a PNG. So a PNG is a picture. So it's a picture. Here we go. It's giving us the relationships, and it is even giving me measures I didn't ask for, but which means I should have said, don't give me anything else apart from the data model. So it wouldn't have gone ahead to recommend this. So it has recommended KPIs, which I don't need now. So let's look at what it has given us. Now, if you're struggling, like, how am I going to create relationships? Here we go. So they tell us they have got dim date, they have connected it, it has a primary key, they have connected it with the delivery date key, and it makes one to many. Then the table stock item, it is stock item, one to many. We saw all this. This, that, it makes that. So you see that everything, what we did, has been done. Obviously, in our modeling, we didn't do the bill to customer. So there is this confusion because we have a key for bill to customer in the fact table here. So which means if I never needed it, I should have removed it. Those are the confusions you find. So, but at least it has given you a start off. Then you can know that how you're going to create your schema. Then here it goes ahead to give you the PNG, which I think this is not the picture I asked for. But it goes ahead giving you the direction that drag this, put it there, drag this, put it there, drag this, put it there. This enables analysis many to many, many to one, one to many, and all that. And if I can speak, all our model layout is done. So this is the layout they have given us. And exactly this is the layout we had. The fact cell was in the middle, all this connected to the fact cell table. And then you can go back and do what you were meant to do. So we are doing that to just give us a snippet of how we are going to run this. So I can go ahead and say, please output an image with all the relationships. You can imagine typing, and so we still have the relationships. Yes. So then mark all the keys related. Let's see whether it will give us the image. It may be stubborn again, it doesn't give us, but obviously now I'm being specific. So when you're specific, AI will always honor to the specifications you're giving it. And you know that garbage in, garbage out. You don't need to explain a lot. Just be direct to make sure that you give all the context. And when you feel like you can't give enough context, or you don't know whether AI will understand what you're talking about, ask it to ask you questions before it executes. AI will ask you questions like, should we do this like this? What does this word mean? Do you need it to be used? Something like that. And when you answer such questions, then you give it a clarity on some of the things. Yeah, it is doing the last week. And to get more from AI, you will always give out the $20 per month. That is around 57,000. You can do as much as you can. So you don't have to limit yourself if you start using this on a scaled up level. But if you're using it like a once in a while, you can remain using the free version. You don't need to pay for it. Okay, let's wait for the last week, maybe as I wait for questions on your end. But I feel like we have exhausted whatever we needed to go for. Yeah, here we go. So just imagine that you went to work the whole day, you're going to work on modeling, and this has been given to you in the morning, even before you make tea. So it means that it is going to be easy for you now to map out, because you see, because I told it to mark every key that is related to the other, and it has made sure that it uses different colors. And even more so, it has given me a summary that dim is green, then here everything that is green, okay, this and this. Obviously the greens we have two, but you may not differentiate them, but one is dark, one is light. So you see the invoice date, the delivery date, that's exactly what we had. The customer key, well and good, even here customer key. The stock item key in red, the stock item key in red. This is the reason why I expanded it to make sure that all the columns were visible, such that if I ask such a question, it's easy for it to give me the relationships. Then it goes even ahead and gives you where it has put the key, it is a primary key. Where it has put FK, it is a foreign key. Then where there is one that is a dimension table. Where there is many, that is a fact table. Where the line is thick, it is an active relationship. Where the line is not, that is an inactive relationship. And even it goes ahead and gives you some notes. Fact cell is a central fact table containing transactional sales data. All dimension tables are in one side, and they filter the fact table. It got a confusion here. The bill to customer key relationship is inactive to avoid ambiguity. You see this dotted one. But for us, it is this dimension, the invoice key, that was meant to be, because for it shows you here one key that is connecting to this, but they are supposed to be two relationships, like how they are here. Now, what can you ask for more? There is nothing. So this is the way how you can use AI to make sure that things are always done in the quickest manner you can. No one is going to ask you, where did you get the idea that the relationship is like this? But people will ask you, why is the report not coming? And you'll always not have answers. So I have shared this on your group such that we can easily use it. But still, whenever you want to share a ChatGTP chat, you just click on share, then you copy the link. So if I copy this link, then I share it with you guys, copy the link, then I share it on WhatsApp, which means when you click on it, you open all this conversation we have done. So it should always be easy for you to share what you have done to your colleagues. Actually, it had given me the image, only that I didn't see it here. It was here, meant to be downloaded. Let me see what it had given me at first before I insisted on specifics. Yeah, you look at what they had given me at first. Not until I asked for that specific prompt. You see what they had given me at first? Because at first I had given a lot of context and it couldn't take time to be specific in the relationship it was giving. But still, someone who has done that analysis, this is enough for you to relate how you're going to create your relationships. You don't need something that is fancy for you to do your part in Power BI. Otherwise, any question on your end? Anything we have left out? Now, I will, by the end of this week, make sure that at least you should have closed off quiz 1, 2, and 3. Because the moment they stay, it's going to be hard for us to catch up with the others when you have a lot of quiz to do. So now we have quiz 1, 2, and 3.